Hi, and welcome to this new presentation about retrieval augmented generation. Before I'm going in the next video to explain you some extension I've done for kernel memory, I want to give you some more insight on how you need to change from the mentality of using only vector search in your RAG pipeline and go to more advanced technique. And this is important. But before going to the code, I want to give you some idea on some concept that we had for a long time in natural language processing that you need to know to better understand how things need to be done. There are two concepts really important in natural language processing. The first is precision. And we are in a context where the user poses a question to the system. It can be a couple of keywords to search, or it can be a complex question, but the system had one purpose during the search phase: to find in all the database, in all the data the system had, it need to find those pieces of text relevant to answer the question of the user. And precision is an important measure because it measures of all the results you are returning back to the user, how many of those results are correct. Because when you search in a system, you can find good result and you can find false positive. So the best situation you can have is having precision 1. It means that for all the things you are returning to the user, all are pertinent to the question. And this was, and remember, this was for a lot of time, the metrics that is most important when you're going to search thing to return to the user. And this is the formula. So precision is defined as the number of positive results and divided by the number of positive results plus false result. So to achieve high precision, your query, the way you are gonna search thing inside your database or databases, because you can have multiple sources, must be really precise. So you strive for returning to the user only the good result, leaving out false positives. Then you have another metrics important, recall. And when you read the definition of recall, you can it can seem that it's the very same definition of precision, but it has a really important difference. So recall means from all the results you are returning to the user, how many of the true positive you return from the old database you have. So it is defined by dividing the number of true positive divided by the number of true positive plus false negative. So it means if in the whole of my database, I have, 100 of true positive. So the question of the user has 100 good result in my system. If I'm returning all of these 100 results, recall is 1. So as an edge case, if I return all of my data, clearly I have recall 1. But clearly you cannot return to the user the all results. So recall means how many positive result I'm missing from the query. And this is a metric that for a lot of time was less important than precision. And in the end, recall measures how many good result we are missing to return to the user. So I'm returning a certain number of result to the user, and all the positive results that are out of my search are missing result, are false negative. So they were deemed to be negative because I'm not returning to the user, so they are considered negative but from my search, but they are positive, so they are called false negative. Basically, precision is how many good results I'm returning to the query, and recall is how many of the total number of true positive I'm returning to the user. These are the two main metrics we used when we use this today as a measure for natural language processing. And those two metrics are not mutually exclusive. We can theoretically reach one recall and one precision, so maximum precision and maximum recall if you return only all the correct result to the user. But you can understand that usually you need to have a trade-off, because if you want high precision, you need to do a search that has a lot of condition to filter out how many false positive we have, and we tend to filter out false negative. So we tend to leave out some positive result. On the contrary, if you want to recall, high recall, you have a more loose searching criteria, so you can get all the positive, but you can get false positive. So usually it is a trade-off. But luckily enough, in the latest year, we will see in this presentation, we have technique that can help tremendously in reaching higher recall and higher precision at the same time. Now, with the introduction of large language model and encoder-decoder artificial intelligence structures, we luckily have more tool in our arsenal. So we can have more advanced way to do a user question search inside your system and giving a result that has higher precision and higher recall. And so we can give to the user a much more focused answer to his question. And this is the basis of a RAG system, Retrieval Augmented Generation. The real problem we had in the past is we already have different way of searching, but the problem is when we search inside search database like Elasticsearch that uses Lucene, the problem is even with the same algorithm is used, even if all the query are using BM25 algorithm or TF-IDF, if we change the way we do query with Elasticsearch, the score of one query cannot be compared to the score of the other query. So we cannot combine result of two different way of searching. So we know that sometimes we have better result doing a certain type of search. Some other time we have a better result doing another kind of search, but we needed to decide upfront, because the problem is we cannot do a series of search with different techniques and then tell the system, okay, I've done a series of searches, and then please take from all the searches the most relevant result, because doing more searches, more different way of searching, is giving an higher recall, because we are returning more record from the system, more pieces of text, and it's possible that the more technique we are using, the higher is the recall, but then we have low precision, because we cannot have a way to take all this result, and from this result, taking only the most important one, until latest years. Historically, precision was the most important aspect, and this because if you return too many results to the user needed to read all of these results before finding the one that solves his or her question. So the idea is Google used us to search something and have the result in the very first page, no one go to the second page. So precision was, for a lot of years, the most important characteristic of your searches. So we always strived for precision. We put all of our effort in having an high precision. But now we have one possible solution, and it's large language model. The latest version of large language model has a very big context, okay? And this means we can stuff a lot of text into the prompt, and the large language model can give attention to a large amount of text. So this gives you another tool on your toolbox, because you can do many query, you can have a high recall, maybe you can do different kind of searches, and you have a lot of results. But instead of returning all that results to the user for the user to read them and find the one you search, you can give all this result to a large language model and ask to the large language model to answer the user question, or to reorder and give to the user the most important part. And this is important because this gives you the ability of strive for recall. So the important thing is you are able to return the most true positive piece of text in your database. And then you will have a lot of false positive maybe, but you can give everything to a large language model and letting a machine in a very fast way extract all the relevant informations. But using a large language model, it can be costly, both in money, because the more token you pass to the large language model, the more you are paying, and in terms of time, because the more token you are passing to a large language model, the slower the language model respond to you, answer to you. So we have another important piece of the puzzle that are called cross-encoding. Cross-encoding is a special version of a neural network that is trained to analyze question of the user and a piece of text and give an output usually in the range 0, 1, but it's not important the range, it's a number. And this kind of neural network was trained to give higher number if the pieces of text is pertinent to the query. And this means that we can have, as for the large language model, we can strive for large recall and then use this kind of cross-encoding neural network to give user question and one by one all the pieces of text you get from your search and then having them re-ranked, so reordered by this kind of neural network. This is usually more computationally expensive from a standard vector search. The by encoding, the vector search you're used for. So when you index your pieces of data, you calculate the semantic vector out from your pieces of text, then store that in a vector database. Then when a user perform a query, you get the query of the user, you encode the query of the user with the same algorithm you used for chunking in your vector database, and then you query the vector database asking, give me the 10, the 12, the 20, the 100 most nearest, more similar vector inside the storage. And this suffers from various problems. I'm not going to tell you this, but one is the asymmetricity problem. It is dimension mismatch because usually the pieces of text is long, maybe 500 token, and the user question is usually small. So some of the encoding is not so good for doing this kind of comparison. The cross-encoding is computationally more expensive because if I'm returning, 100 results with different techniques from my database, I need to call this kind of neural network 100 times with each time the question and the different pieces of text. Usually the API allow you to pass an array of documents, but internally it needs to run this neural network for all the passage you have. But this is really powerful because it does not suffer on change of dimensional problem because the neural network is analyzing the question and all the possible text one by one, and for each couple gives you a score that tells you how pertinent is the pieces of text to the question of the user. And this little schema was taken from the SentenceBear site and show you the difference between by encoding and cross encoding. In the by encoding, you are encoding separately, differently the question and the pieces of text, and it's much more powerful because you are encoding the pieces of text only during indexing, while the cross encoding work with the question and the pieces of text at the same time, and it needed to be done for each possible result, but it is much more powerful. And with cross-encoding, we are introducing the concept of ReRanking because there are a lot of studies that demonstrate that if you have infinite computational power and instead of using other technique, you use cross-encoding to search inside your database, you probably have a solution that is better of everything else. So if theoretically you have, 1 million pieces of text in your database and you have a user question, if you have enough power to compute a cross-encoding of all the 1 million pieces of text compared to the question, and you order the result with this cross-encoding, this technique is better for anything else. It is better of anything else, but it is not feasible with computational power you have. So you need to use a hybrid approach where you have 1 million result and you use different technique, maybe BM25, keyword search, vector search, other search. And so you are, for each of this technique, you get a candidate, maybe a 100 result. So instead of having 1 million candidate running through your ReRanking function, you have other tools in your toolbox. I explain it to you, BM25, keyword search, everything. And you take a small subset, maybe for each technique you return maybe 20 results. So you use 5 technique, 20 results for technique, you have 100 results, maybe there are duplicates, so you maybe have 80 results, and then you run those 80 results through a cross encoding. And this is the best of both worlds. You use some algorithms that are very, very fast on giving you some information. You are using them to maximize recall. So your purpose is trying to get as much true positive as possible. And you don't care about false positive because you know that your result will contain a lot of false positive. But thanks to a second stage of cross encoding, you will reorder all the results of this different query and leaving the false positive in the lower rank and making the true positive go up in the first position. And this gives you the best of both worlds. A first stage in which you very quickly try to have a high recall, and the second stage in which with a cross ranker you can take all this result and reorder for precision. So first recall, fast algorithm for high recall, and then a slower algorithm for precision that work with a reduced number of elements filtered by the first. Well, nothing is a silver bullet. So cross-encoding can have disadvantages. First of all, you need to run another model on the possible candidates. So you need to use maybe GPU for having a fast result. Or you can pay a system like Cohere that have an API to rank things, but clearly this is another pieces of external API you're putting in your system and it's going to cost you money. And these models are more or less resource intensive. As usual, we have a lot of this kind of model. A lot of models are free and you can find from Hugging Faces, but some models that are better are more computationally intensive because they are bigger models. So you need to evaluate this. So this is another thing you need to do when you design your RAG pipeline. So you need to understand which of the cross-encoding you're going to use. And maybe you will use more than one cross-encoding to have the best of both worlds, local, small model, and if the model is not good, you can scale to a more precise and costly online model. And also, it adds complexity to your search pipeline because instead of having user query, vector search, or keyword search, and then return the query to the user or pass the candidate to a large language model, you have more complex query where you have user question, many search strategies, the duplication of the search results, then pass to a ReRanking, and finally pass to a large language model or to the user. But I'm telling you that this is the very game-changing model in your search pipeline. ReRanking is what gives you the ability of strive for precision and recall at the same time. First recall, then precision with a ReRanker. And even if you have these disadvantages, the result will be very, very appealing for the user. To conclude this video, this is what I usually call an advanced approach to RAG, and it's the start of an advanced approach to RAG. So you have the very first version of RAG that you are seeing in a lot of sites where it's simple. You have a text, you separate into chunk, you index into a vector search, and you use by encoding to take the user question and do a vector search. And here you have the result you are passing to the large language model. This kind of technique is proven to be good, but not in all scenario. And especially if you have a large amount of text you index inside your vector search, inside your vector database, vector search usually is going to give you a lot of false positives. So precision will be low. And even if the vector search usually have a good recall if you take a lot of vectors, you know that it's not possible to pass a lot of information to the large language model, unless you want to pay a lot of things because you are going to stuff a lot of tokens inside the large language model context. So the first step, if you want to make your RAG pipeline more advanced, the first thing you need to introduce is the ReRanking, because it gives you the ability, it opens to you the ability to parallel use a different technique for searches, and maybe one technique is better for one kind of query, another technique is better for another kind of query, and so on. But you don't worry about this. You can use as many techniques you want, because you know that all the results that will have a high recall will be passed to a stage that will clearly reduce the number of false positive and bring the true positive up in the very first results. So you will have you can have your cake and eat it too. So the first thing you need to do in your RAG pipeline is introduce ReRanking. This will open up a lot of possibilities.